Let's jump right in. Welcome to The Explainer. I am absolutely thrilled to have you here today. Get ready because we're embarking on a breathtaking and honestly deeply terrifying cosmic journey. Today, we're taking the ultimate leap into the dark. We're looking at one of space's most compelling, mind-bending mysteries, and we're asking the ultimate question. What would actually happen if our home planet, Earth, fell into a black hole? Now, it sounds like a scenario straight out of science fiction, right? But the physics behind it, they are incredibly, undeniably real. Think about this for just a second. Our solar system has been doing absolutely fine for about 4.5 billion years. That is a massive, massive streak of cosmic luck. I mean, it strongly suggests we've literally never come into contact with a black hole in all that time. We've just been safe, orbiting our predictable, cozy little sun. But what if that luck just ran out? What if the universe decided to throw us the ultimate cosmic curveball?
Section 1, the Cosmic Wandering Menace. Okay, let's dive into this. To really understand the threat, we first need to understand the predator we're dealing with. 100 million. Now, that's not the number of stars in some random cluster. That is the eerie, frankly staggering estimate of exactly how many black holes are believed to exist in our Milky Way galaxy alone. Think about that. 100 million invisible traps just scattered around our cosmic neighborhood. But, not all black holes are created equal. We essentially have two main types here. On one hand, you have supermassive black holes. These are absolute monsters. But the good news is they're generally stuck right at the heart of every galaxy, including ours. We know exactly where they are. But then, on the other hand, we have stellar mass black holes. And these are the ones that should probably keep you up at night. They're smaller, sure, but their gravity is so intensely dense that they aren't stuck in orbit around another object. They just wander, totally freely, through space. They can actually creep up on you. In fact, the nearest known stellar mass black hole is thought to be just under 3,000 light-years away, boasting roughly 9 times the mass of our sun. So the absolutely crucial point here is understanding why these wanderers are so incredibly dangerous. Black holes are remarkably dense. They're so unbelievably heavy that they literally bend space and time inwards. And here is the truly terrifying part. They do not emit any light. No radiation, nothing. You literally cannot see them. They are the ultimate cosmic stealth predators, just sneaking around entirely undetected, unless they happen to interact with a bunch of nearby matter.
Section 2. Earth's gravitational nightmare. Imagine one of these stealthy, stellar mass black holes wandering straight into our solar system. I'll tell you right now, things are going to escalate very quickly. Let's walk through exactly how our destruction would play out chronologically. Step 1. As this extraordinarily dense object approaches, the gravitational pull of our entire solar system completely shifts. Planets are violently torn from their orbits, and they're likely going to smash right into one another. Step 2. If we somehow miraculously avoid a planetary collision, well, we become a cosmic dartboard. Asteroids are easily torn from their paths and hurled right at us. This Earth-wide asteroid bombardment, causing widespread fires and total destruction, well, to put it mildly, that would not be ideal. Step 3. As we get closer, our very atmosphere is completely stripped away and just sucked right into the void. And finally, Step 4. The planet itself physically breaks apart. Now, if you're sitting there wondering, hey, could we somehow survive all that planetary fragmentation? Well, no, absolutely not. Even if the fires and the planet smashing didn't get us, the environment is now completely flooded with intense radiation. This radiation is created from all the other broken apart material, torn planets, and just cosmic junk violently grinding together. Humanity would be long, long gone before we even reach the main event. Section 3. Crossing the event horizon. Let's take a deep, collective breath here and just imagine the remains of our planet drifting ever closer to the edge. Because once we cross that threshold, the point of no return, we encounter one of the most bizarre concepts in all of astrophysics. It's a real scientific term, believe it or not, called spaghettification. Some scientists believe that at the absolute bottom of a black hole lies an incredibly dense point called a singularity. Our poor Earth would be drawn into this massive cosmic funnel and broken down, literally molecule by molecule. Everything gets stretched out incredibly thin, exactly like a strand of spaghetti, until matter exists simply as atoms stacked on top of atoms. Section 4. Theories of the unknown. The hard truth of the matter is, the only way to escape being sucked in is to travel faster than the speed of light, which means moving faster than the black hole's gravitational pull. And let's be real, we are nowhere near capable of doing that.
Because no information whatsoever escapes a black hole, we simply don't know for a fact what happens at the very bottom. We have to rely on cutting-edge guesswork, specifically 3 distinct theoretical outcomes. Now, what's really interesting about this slide is we just covered the first one, total destruction via spaghettification at the singularity. But outcomes 2 and 3, they completely change how we view the universe. Let's look at outcome number 2, the portal theory. Because black holes already bend time and space so extremely, many physicists think they might actually be folds in time and space. They wouldn't be holes at all, but rather doors. Matter would go in, travel through this fold, come out the completely other side of the universe, and violently expand outwards, exactly like a Big Bang. And then there is outcome 3, which is frankly just astonishing. Some scientists hypothesize that instead of being violently destroyed, any material that touches a black hole is actually converted into a near-perfect hologram. So, in this incredibly wild scenario, Earth just turns into a holographic projection, and we wouldn't even notice the difference.
Section 5, a miniature black hole. Let's move to and see how this builds.
Into something a bit closer to home. We've talked a lot about wandering space menaces, but what about right here on our own planet? Let's zoom back to reality for just a second. While we've established that we've been super lucky to avoid stellar black holes for 4.5 billion years, could we actually be our own worst enemy? Is humanity at risk of creating black hole danger right here on Earth? I know, it sounds totally absurd, but scientists have built something called the Large Hadron Collider. It's this massive, multi-billion-dollar machine designed to smash particles together at basically unimaginable speeds to help us understand particle physics and the very origins of the universe. But here is the fascinating catch. Theoretically, these collisions could actually be powerful enough to generate a miniature black hole right here on Earth.
And that brings us full circle to a deeply, deeply provocative final thought. We know our universe is currently expanding. We can actually see it happening. We also know that it started in a very hot, incredibly dense place before exploding outwards in the Big Bang. Does that sound familiar? Think back to the portal theory for a second. If matter falling into a black hole gets compressed, funneled, and shoots out the other side to expand outwards, could our entire universe, could we have come out of a black hole? It's a massive, mind-boggling concept to leave you with today. Keep looking at the stars, keep looking at the science, and most importantly, never, ever stop questioning.